Hi, my name is Dylan Edmiston, and today I'm going to show you a simple usage of Motec's RefSync capture, how to analyze the capture to complete your ECU setup, and hopefully get the engine started using that data. So, simple description of what RefSync is. Ref is your crank reference position, sync is your cam synchronization. So those are two sensors, whether they're magnetic or Hall effect, or you can also have a logic level. Um, and the ECU uses those two sensors to know where the engine is in its cycle in order to determine when to fire the injectors and your ignition coils. So it's of vital importance that you get these settings right. If they're wrong, you may get a lot of errors, or the ECU may not start the engine or shut down. So to do the RefSync capture, we go to Utilities, RefSync Capture, and it opens up this dialog box that's empty right now with the capture button. So before I do the capture, I want to talk about what we're going to be looking at. So if we go back to our setup page for RefSync, which is achieved by adjust sensor setup, RefSync sensor setup, I'll see that one, it asks for what type of mode there is. So in Motec, modes 0 through 9 are non-OEM modes that utilize a single cam trigger per cycle of the engine. So a common setup you'll see is 60 minus 2 setup, which would be um, option 7, um, or rather option 5. What's missing cycle. Um, However, there are some OEM modes that Motec has created because what the OEM does sometimes is they'll have some odd patterns in their cam and crank trigger wheel. So instead of having that single tooth, they may have four evenly spaced teeth, or say three unevenly spaced teeth with a missing tooth. And normally, if you try to get the ECU to work with that in modes 0 through 9, it'd begin to freak out because it doesn't know how to respond to, say, that missing tooth or an extra tooth in your cam wheel. So Miltech's gone through the pain of figuring that out and putting in some logic to, when there's a missing tooth, say it's like fake when there would be that tooth where it says the missing tooth is. There's also your crank reference teeth, which is the number of teeth on the crank wheel per revolution. Fairly simple. Tooth ratio, which I'll leave alone for now. If you want extra help on that, you can just press F1 to open up the help menu, and Motec gives a pretty good explanation on that. Crank reference index position. What this does is it allows the ECU to determine what your index tooth is on your crank wheel. So the importance of that is to know which tooth should it reference as your point for top dead center to know when it's going to fire the injectors or fire the coils. So what this does is it looks at your cam sensor, and when you have a trigger from that, when does that trigger occur before your top dead center occurrence? So by doing this, it uses that trigger and it makes the next uh, reference, or your next reference tooth your index tooth. If you press F1 and browse through this, you'll be able to read a little bit more about it and understand what the ECU is doing. And also, this is in degrees before top dead center. And your other options are your sensor type, your edge polarity, and your voltage levels, which we'll be able to determine in our RefSync capture as well. So I'll go ahead and do that right now. And for this test, I've gone ahead and unplugged the injectors and disconnected the ignition system so I don't have the engine try to start up on me right now because I'm just doing the simple setup. My ECU right now, the configuration is bare basics. I start off with um, a new config just to prove that I'm able to get the engine started up relatively quickly um, with this process. So another thing I've done is I've disconnected spark plugs 2, 3, and 4, with this being a 4-cylinder engine and cylinder number 1 being the reference for top dead center. So I'll go ahead and do the ref sync capture and explain the importance of doing so. So I'm just going to go ahead and start cranking the engine and then press capture to get a full cycle of the ref sync capture. As you'll see here, it pops up this screen with a bunch of lines, essentially. Your yellow line represents your reference voltage, and your sync time, or your blue line reference sync voltage. And the x-axis is time, y-axis is voltage. So we can, by using the screen, we'll be able to see what our sensor type is, if there's any voltage offset, as well as what our edge polarity is. So going through those, we can see that this is actually a magnetic sensor for both sensors. I can tell this because a Hall effect sensor would be a square wave as opposed to this sinusoidal wave we have from both sensors. And I'll go ahead and show you what a Hall effect sensor would look like real quick. So just an image I found online. We can see here the sync sensor has a square waveform where it just shoots up quickly, levels off, shoots down, or perhaps it's shooting down, leveling off, shooting up, depending on what our edge polarity is. So that would be a Hall effect sensor. We're still on this screen. The reference sensor is Hall effect, or is magnetic. So in our ref sync setup, we have 2 and 2 as the sensor type, which is good because that corresponds to our ref sync capture. The other thing is what is the edge polarity? So there's rising edge and falling edge. For a magnetic sensor, your edge polarity corresponds to your zero crossing. So as we can see here, following our sync voltage, it goes on 0 for a little bit, goes up, and then shoots down, and that's where our zero crossing is. So in this case, the sync sensor is a falling edge sensor. And if we were to look at the ref sensor as well, that is also 0. So essentially what you're looking for is that sharp drop. Now looking at another example. In this case, a bit bad resolution, but the audio still gets across. If we're looking at our sync sensor, we see that the zero crossing occurs on the sharp upward increase. So in this case, this would be a rising edge sensor. For Hall effect, you can have it set as either rising or falling edge. What that does is just says where you are on the side of the waveform. So if we were to set it as rising edge here, you'd have a trigger on this edge of the signal. If it were falling edge, our trigger would be on the other side. There is an importance in what you have it set at, because sometimes if your edge is close to, say, these missing tooth we see here, what could happen is that, say, higher RPMs or varying engine loads, you may have some slop in your chains and your valve train, which will shift the sensor reading just a little bit. So what we could see is this sensor voltage, or this sensor drop, trigger over, and if your index tooth is too close to that, you may end up the ECU may jump an index tooth just because of where the sensor voltage read at. So it's important to know where your sensor edge is relative to where other teeth are. So in this case, with this setup, I'd probably end up using a rising edge sensor just to avoid um, my falling edge sensor, or if I made it falling edge, to make sure it doesn't go past these missing teeth and miss a cycle of synchronization. Looking back at our ref sync capture we just made, we can also see that there's no voltage offset. So if I go to these settings, I see Hall effect, fall, 0 voltage offset, and same for sync. So that's already set up well. Going back to it, to look at the number of teeth on it, simply count the number of pulses from your ref sensor between the two spikes in the from the sync sensor. So in this case, I was able to read 24 teeth. But as we look in the Motec menu, it says number of teeth per crank revolution. So what we saw there was 24 teeth per cycle of the engine. In each cycle, you have 2 crank revolutions, so 24 divided by 2 is 12. And then in the ref sync mode, if we were to press F1 and go through the different files and just see what it is. In this case, I know it's a multi-tooth mode. I'm able to go through and just validate that what I have here is in fact a multi-tooth mode. So I'm going to go ahead and input that in. The next important thing is crank reference index position. As I already urged the importance of making sure you get that right. So what I did with this test as well is I unplugged spark plug cylinder 2, 3, and 4. Cylinder 1's top dead center. So the effect this has is you can see the effect on the voltage level for your crank position sensor. So what's going on here is I've taken out most of the resistance from 3 of the other cylinders by just leaving them open. But in cylinder number 1, as I'm going through the stages, first I have intake, so I have low resistance from the spark plug not having any effects since not closing it. When I go into compression, I'll have a relatively high resistance. And then combustion, just varying resistance going through the cycle. Exhaust, you'll have the least resistance because at compression you will have your most resistance due to the effect from the spark plug being in there and preventing the air from escaping, therefore putting a vertical load on your cylinder and pushing it down. So looking through here, we can see the varying levels and voltages, and this happens because as the speed of your crankshaft varies from having that spark plug in there, your voltage level is changing. So having a trigger wheel go past the sensor faster will increase the voltage level. So as we can see here, we have a high voltage level. This is actually where our peak is. I can assume that's where our intake stroke is because the valves are opening up, air is being sucked in, and there's not much resistance going on with that valve open. So then I can assume right here is actually where our top dead center mark is. So knowing from the Motec help menu, it says it wants to know degrees before top dead center of when you have the sync zero crossing um, in reference to top dead center. So we know this is roughly top dead center, and I'd go to the zero crossing of that point. And then to determine degrees, what I do is just count the number of teeth before my zero crossing from the sync sensor. So I can see one, one, two, and then a little bit past two. So being that this is 12 teeth per revolution, I know that's 60 degrees plus whatever little extra I have there. What you can what you can do to determine that little extra is you can just look at your time between this reference tooth and this one. The time between those and where your crossing is for your sync sensor. That way you can determine the approximate number of degrees that that sensor occurred. In this case, I already did the math. I had 60 plus about 10 degrees from the difference of the sync tooth in between those two teeth. So that gives me a crip value of 70. So if I go back to my ECU setup and I put in 70, now we have all the essentials for our ref sync setup. Now, this method isn't perfect. It gets us pretty close. In the case for this engine, I took off the crankcase, or I took off the timing chain cover as well as the um, valve cover, and I was able to line up the sync sensor or sync trigger with the sync sensor, and then measure with a protractor the number of degrees before top dead center. So this method was a few degrees off, but it should still get us the results to help us get our engine fired. As you can see, I had several um, ref errors. Right now it says ref sync not synchronized. If you just go into your diagnostics page and press enter, it clears your errors. Right now the engine's not running, so ref sync can't be synchronized. So if I go to my ignition page and fuel page, I can see that I just have a baseline map because I have not done any tuning to this engine yet. As I said before, completely blank config. I just put in the bare essentials such as number of cylinders, efficiency, and load calculation methods, injector characteristics, such as seen here, my ignition setup along with dwell time, the bare basics just to get the engine up and running. So for my ignition, I set it to a fairly conservative ignition. I just set the whole map to 5 degrees before top dead center, just because I know that's relatively safe to help get this engine started. My fuel curve right now just standard set at 50. That's sort of what we're going to play with if the engine doesn't start. I'm not going to play with an individual cell. I'm actually going to just do an overall trim, which essentially just trims the whole table. So before we try to get the engine started, you need to plug the injectors back in, put the spark plugs back in, so we can actually make mini explosions. Okay, and now I have my injectors and spark plugs hooked up again, so we should be able to get the engine started. So my reference setup is good. I'm gonna try my first crank and see what happens with the engine. And I have a few sensors set up just to monitor some of the vitals. Other than that, setup's pretty simple. One thing I have is throttle position just to make sure that throttle's not stuck. Um, Oil pressure just to check out what's going on with that. Fuel pressure, make sure I have that. If you don't think I have that set up. Anyways, we'll see what we get right now. So we got it started up and then it died relatively quickly. So I'm just gonna do a little fuel trim and see if that helps keep it running. And I actually went ahead and killed the battery because it's not been on the charger for a while. But we can see the results I was able to get from that. Just from adjusting the fuel trim, we'll be able to get the engine started and idling safely. I did this earlier and was able to get it up and running first try. Um, so that's the simple method of getting it done. And this just gets our engine running. That way, when we take it to the dyno and are ready to tune it, we know that the engine can start, and we have idle worked out. We just need to tune the rest of the fuel map as well as ignition. So that's all I have today. Um, if you have any other wonders about, like, well, I want to learn more about RefSync, Motec has a few webinars posted on their site, as well as some additional documentation on the proper use of RefSync capture, what each sensor is, how to look at whether it's magnetic or Hall effect, and help ensure that you get your setup done properly and help you get it done faster.